Hi guys, welcome back to my YouTube channel. Today's video I'll be explaining about the sampling variable and central limit theorem. Introduction. As you all know, my name is Sanjana, pursuing my engineering in Sri Venkateshwara College of Engineering, 3rd semester. Section is Chanakya, section subject mathematics, topic sampling variable and central limit theorem. Introduction to sampling variables. Sampling variables are statistics calculated from samples drawn from a population. They help in understanding the characteristics of the population without surveying every individual. Common sampling variables include sample mean, sample proportion, and sample variance. Type of probability sampling. Simple random sampling, cluster sampling, systematic sampling, and stratified random sampling. Importance of sampling in statistics. Sampling allows researchers to make inference about population efficiently. It reduces time and resource needed for data collection compared to a census. Proper sampling techniques enhances the reliability and validity of statistical conclusion. So what is sampling? A process used in statistical analysis in which predetermined number of observations are taken from a larger population. Types of sampling techniques. There are several sampling techniques including random, stratified, and systematic sampling. Random sampling ensures each member of the population has an equal chance of selection. Stratified sampling divides the population into subgroups and samples from each, improving representativeness. Types of sampling method. First one is random sampling, gathering the representative sample from a population where each member in the population has an equal chance of being selected. So example is using a random number generator to select student in a class to compare a task. Stratified sampling. Smaller group of data within a sample are represented proportionally to the population. Example, finding out a favorite soap opera from different age categories of people in a year group. Next one is systematic sampling. Every member in a population is given a number. After first member is chosen at random, the remaining members are chosen from given interval. Example, a list of people with their names in alphabetical order are numbered. The fifth person is chosen randomly, followed by every subsequent eighth person. Non-random sampling. Convenience sampling is used to ease the data collection. Volunteers usually collect data. Example, asking people at a given location about how they communicate to the work is capture and recapture, collecting a sample of data from one location at different points in a time, making the individual to estimate population size. Example, a sample of woodlice were captured, marked, and released. Another sample of woodlice are captured 5 days later and number of marked woodlice are counted. So this is about the type of sampling techniques. Next comes the central limit theorem. So what is the central limit theorem? The central limit theorem CLT states that distribution of sample means approaches a normal distribution as sample size increases. This holds true regardless of population's original distribution provided the sample size is sufficiently large. The CLT is fundamental in inferential statistics, enabling hypothesis testing and confidence interval estimation. So as in the picture, we can see there are 68% of all values are within the first standard deviation of mean value. The 95% of all value are within second standard deviation of mean value, and 99% of all values are within third standard deviation of mean value. Condition for central limit theorem. The sample size should be generally at least 30 for the CLT to apply effectively. Samples should be independent of one another to maintain the validity of the theorem. If the population is normally distributed, the sample means will be normally distributed regardless of the size. Next, Implications of central limit theorem. CLT allows statisticians to use normal distribution for making inference about population parameters. The facilitates of the calculation of probabilities related to sample means, enhancing decision making. The theorem underpins many statistical methods including regression analysis and ANOVA. Practical application of sampling variables. Sampling variables are used in market research to predict consumer behavior. They play a crucial role in clinical trials when evaluating the effectiveness of new treatment. The quality control. Sampling variables help monitor production, process, and ensure product standards. So, applications mainly include consumer behavior, purchasing habits, and consumer motivations. Next is common misconception about central limit theorem. The common misconception is that the CLT only applies to normal distribution population, which is incorrect. Some believe that sample size below 30 cannot yield normal distributions, which can be misleading in certain contexts. It also misunderstood that CLT guarantees a perfect normal distribution for all sample sizes, whereas it approaches normality asymptomatically. Next is the visualizing of central limit theorem. Graphical representations such as histogram illustrate how sample means coverage to normal distribution. The spread of sampling distribution is determined by standard error, which decreases the larger sample sizes. Visual enhance understanding by showing difference between population distribution and sampling distribution. Conclusion and key takeaways. Understanding sampling variables and the central limit theorem is crucial for effective data analysis. Proper application of these concepts leads for more accurate and reliable statistical inference. Mastery in the principle empowers researchers to make informed decisions based on sample data. So this is all about the central limit theory and sampling variables. Hope you all like the video. If you like the video, please do like, share and subscribe.